complex numbers just look like that. It's a plus or minus bi. We don't really work with a lot of the things you can do with those in Algebra 2. I think they still graph them in pre-calc. It's not a big deal. It's super easy to do. But the reason that they write this out, this is just the natural form of a complex number. So if there is and they only come in, and they always come in pairs. And the reason that they come in pairs is because the way that the complex numbers are created is that you had to take square roots. Okay? And you took square roots over an equal sign. So that's why they're always plus minus. So if you have a 2 plus I, that means you have to have a 2 minus I. Okay? And so on and so on and so on. So when we want to write out the idea of the polynomial of least degree, remember we were saying that it just means however many zeros you have is the degree you're going to wind up with. And we're going to have a coefficient leading term of 1. Okay? If we do that, we know that we're going to have a 2 minus I. So we'll also have to have a 2 minus I. In this scenario, the zeros of 3 and negative 4 are super easy to work with. If you have a 0 of 3, what's its term? X minus 3. And if you have a 0 of negative 4, what's its term? So the first thing I would do is I would work with those. And you get that. That's easy. The other part that we want to look at is when we're dealing with these weird complex numbers. When I'm dealing with those guys, remember that just means this. It's x minus the 2 plus I, and then x minus the 2 minus I. Right. From here is where we start to make things a little bit weird. And I want to take all this to a clean one. So right now we have x squared plus x minus 12. And I'm just going to distribute my negative into those parts real fast. Okay? What do you mean?
Like in the brackets,
Mm-hmm.
it says x minus.
Remember when you're dealing with zeros. If this was my 0, what's its term? Exactly, and that's the same reason. That's the same thing that we're doing. So if your 0 is 3, you know it's x minus 3. If your 0 is negative 4, you know it's x minus a negative 4, but we write it as plus. So we're still writing it out the same exact ways as we were before. Right. Now here's where things get interesting. In this case here, I'm going to show you guys this little trick. I'm going to put these in parentheses. And let me use this subtle thing called U substitution. I'm going to let U equal x minus 2. This little trick of what's called U substitution allows you to do weird things easily. If that makes any sense. Because watch what happens. We know that this guy comes along for the ride, so he's still there. Now I get U minus I, U plus I. And what do? Yeah. Notice how that generates a difference of squares. See how that generates a difference of squares? Well, yeah. Now that I point that out, it's a difference of squares, which means that this becomes U squared minus I squared. But what is U squared? So now, all you have to do is FOIL out the x minus 2. It's junk squared, so remember, it's junk times junk. Don't kill a puppy. What's I squared? -1. What's minus a -1? Like I said, it's not a difficult scenario, a difficult setup. It just looks really, really, really weird. Okay? So you have two trinomials now. You have x squared plus x minus 12 times x squared minus 4x plus 5. And it's just a nasty FOIL problem. You got to distribute out 3 times. Okay? And that's what you would get. You get a 4th degree polynomial now because you've got 4 zeros. The trick was, excuse me, setting it up in terms of that u. That's the weird part. That's where it gets a little weird. You don't have to use the u. I suggest using the u because it's a way to keep things clear. What I mean by that is you don't get lost in all the extra junk that's going on right off the top. Right. You don't have to use it that way. It's just a nice little setup. We use that u substitution trick half a dozen times or so throughout the school year. I'd say somewhere in that neighborhood. Half a dozen. Do you need me to multiply all that out, or did you figure that part out? Let's try another. Sorry. Yeah. So I want to write out the polynomial of least degree. Then I have a -5 for a 0 and a 4 minus I for a 0. Again, the reason why we're not writing it out in terms of what is the degree that you should wind up with? Third degree. You should wind up with a 3rd degree polynomial here because you have 4 minus I, which means you have to have a. So you wind up with a 4 plus I as well. Okay. And usually after you do one of these or 2 of these, you'll see the pattern. And that's why I like to use this u substitution, because it kind of involves it out real quick. Just like earlier, distribute. And now I'm just going to group. That u substitution thing, what I'm doing here, I'm just saying I'm going to let u equal x minus 4. So you get u minus I, u plus I. You can use this substitution trick anytime. Okay? Anytime. It works for anything. Anytime that you come across something that looks really, really awful, this is a nice little trick. Right. And that's how this generates. This is how I wanted to show you guys that it generates out difference of squares. So this is a u squared minus I squared. So if that's that. And then distribute out through 5. Oops. Yeah, plus 5x squared. 585, I believe.
Yes.
There you go. And there's your polynomial of least degree. It's like I said, I think going into a Friday with that, with having only 7-8 minutes left of class on Friday, I was trying to show you guys how to do that. Yeah, no. That's why I stopped. Show you the other little quick thing we'll start today. We'll do 2 parts today. Excuse me. The other thing I wanted to look at was something we've actually done. So I figured it wouldn't be so bad to start this up for today. I want to talk about quick graphing of polynomials. And then we'll get into more and more of how do we find relative maxes and differential operations. We've actually done this, but you guys did this when you had the whole, where you had to factor it to find your zeros. Today, what we're going to start out with is it's going to be written in factored form, and then you guys have to figure out your dance moves from there. It's relative, yeah, because it's less work. But do you need to do that? If you look at this, what are your tails doing? They're up, aren't they? Right away, you should be able to tell that because you just multiply the first 2 terms together, you get x squared. There's no other leading term coefficient to worry about. All right, so you know it's going to be an up, up. Where are your zeros at? Could you figure out where your y-intercept is? Where is it? It's -8, isn't it? Yeah. All right. Sometimes you can get a little bit of extra information. Quadratics are easy. I mean, we've all graphed these before, so it's not. Okay. There's one change of direction. I'm not worried about where it is. I could figure out all that fun stuff, but we've done all that before. I just wanted to start with plotting off of zeros, tails. Okay. Let's try another one. First thing you worry about, let's see, we have f of x is 1/4 times the quantity x plus 2 times the quantity x minus 1 squared. Now, if you look at that, obviously it's a 3rd degree polynomial, and which means you'll have 2 changes in direction. Okay. Excuse me. What does junk square stand for? Yeah, multiplicity. It's junk times junk. That's multiplicity. When you have multiplicity of 2, what happens at that value? Changes direction. Good. So in this example here, you have your tails. It's a 3rd degree polynomial. Your tails are down up. Your tails are down up. You have zeros at -2 and 1 with multiplicity of 2. The reason why we say it's multiplicity of 2 because there's 2 of them. Okay. We go from there. So again, this is something we've done. Bless you. We know our tails are down up, bless you. We know somewhere it's changed direction. You know it's got to go up. Do that. Without the use of a gravity calculator or, multiplying everything out, we wouldn't have to worry about the other parts. But that just gets us a rough sketch. It's kind of nice to do something pseudo-simple for a Monday. Yes, ma'am? Nope. It just tells you if it's positive or negative, doesn't it? Think of that as, think of this as that value of A. Remember when we had A's out in front of things to tell whether they're positive or negative? That's all that is. It's a scalar. That 1/4 was a GCF that you were able to factor out prior to factoring. If that makes sense. Okay. Okay? Try that one. Zeros, plus or minus 3, and negative 4. Tails, up, down. Did you just go the evil crab?
No, no.
Something like that, I guess. That's something. Where's your y-intercept? You're right. Negative 36 gives the negative 9 and 4, but we got to multiply that by a negative 2, and it gives you 72. I was just about to write that. Not this good. Yeah, it's close-ish. I wrote it down. Tails. Tails are down, down. Okay. These zeros have multiplicity. They have multiplicity of 2, which means they change direction at the zeros. Right? So it's got to move up, change, got to come back up, change. You're not buying it, are you? It changes direction here because of the multiplicity. It's a duplicated zero. Whenever you have zeros that are, if there are 2 of them at the same spot, it doesn't go through it, it changes it. So it changes here, and then it changes here. Somewhere in between, it had to go from down to come back up to go back down. Now, these are those things that it doesn't necessarily mean that you're going to have 3 changes of direction. Oh, I'm sorry, we do, but sorry, it's not showing something. I'm thinking something different. Oh man. Yeah, exactly, right. All right, let me give you guys a handful of both of these types. There wasn't all that much with this. Tomorrow, remember, we'll be gone. I'll be gone. Seth will be gone. Judkins will be gone. Gonzalez will be gone. We're all doing that math team thing. It's gonna be awesome. Yeah, we need to sabotage the sticky board. So if anybody in the room happens to be able to know how to sabotage them, we need a little help with that. We'll turn their water on. Alright, let's do this. Go ahead and see if you guys can do a couple of these. So, I was talking about 376. I'll put those PDFs up now before I forget. The grouping of that 55, 59 is basically you need to just use your graphing calculator to approximate some zeros. So that should not be very difficult. I'm kind of thinking we should be able to get everything done by the end of this week. No. I think we'll be done with polynomials. Bless you. Yeah, we'll test on Friday on this stuff. Okay. Yeah. There's a little bit of I think so. So what I'm thinking here, guys, I put up here on the 6, 7, 6, 8 on the calendar. Tomorrow, I'll have like a little bit of like a worksheet or something like that for you guys to do with all this. And then on Wednesday, we'll finish the we'll finish 6.8. It shouldn't take that very long to do all that. I'll have a little worksheet for it. Whoa, language. And then we'll do the we'll do that. Yeah, the stuff that's left over here that we have left to go through is just how do you write the actual equation out, given points, stuff like that. So that doesn't take long. All right.